Good evening, everyone, and thank you for joining us this evening. So in this evening's online revision webinar, I will be going through a set of 20 multiple choice questions, which you hopefully should have in front of you along with your calculator. And these questions, the way I made them was to try and emulate as close as possible the end of year VCAA section A of the exam 2. And these questions that I've put together, they are extremely similar to those that have had very low correct response rates. So ones that are typically about 50% or less of students that get them right. So before we get started, I think it's always good to double check our calculator document settings. So the way we're going to do that is I'm just going to head back to the home screen by pressing the on button, and then going to press 5 for settings, and then 2 for document settings. So the document settings that are most appropriate for specialist mathematics for the display digits, they can be float or fixed. It's really up to your preference. I like to keep them in float. With angle, it's incumbent that you keep it in radians mode. Most of the trigonometric calculations we do will be in radians. Exponential format, we will keep that in normal. Real or complex, please do make sure that is in rectangular mode. Real mode, that's really for maths methods. Rectangular mode is what will allow us to do things like complex solve and complex zeros and etc. Calculation mode, of course, you want that in exact form as specified by the instructions at the start of every examination. And then everything else, well, it's not too much of an issue, but mainly make sure your angle is in radians, your real or complex is in rectangular, and the calculation mode is in exact. If you do have to change it, make sure that you tab all the way to make default, so that any new document you create will have these settings as the default settings. So I'll press enter on that. I'll press OK, and then I'll head back to the document I had open. Okay, so without further ado, let's make a start on the very first question. So question 1 is a question where we're looking at an equation that's defined implicitly, and we want the equation to represent a circle. So the equation is 3x squared plus 3y squared minus 7by plus 3 equals 0, and b is a real constant. This question is similar to the 2008 exam 2, question number 2, which only 42% of students got correct. Okay, so let's see how we can use our calculator to get this question solved. So I'm first going to open a new page, so Control-I, and I'm going to open a calculator page, enter. So I'm simply going to type in the equation, but before I do that, I'm going to ask it to complete the square. So to get complete the square, menu, 3 for algebra, and then 5 for complete square. And now I'm simply going to type in the equation as I see it on my paper. 3x squared plus 3y squared minus 7b. Make sure you use a multiplication there, otherwise the calculator will think b and y are a single variable. The 7b times y plus 3 is equal to 0. And I'm going to ask it to complete the square over both the variables, x and y, so comma x, comma y. Enter. So now the calculator gives back to you an equation where it's completed the square in both x and y. And what you might notice is that the coefficient of x squared and the coefficient of y squared are both 3. So that's a good indication that we are looking at a circular via. So how do we know that we're looking at a circular via? Well, we want the right-hand side of that equation to be a positive number, because the right-hand side represents the square of the radius. So to get the answer to this question, we're simply going to use a solve. Menu, 3 for algebra, 1 for solve. And I just want to copy the right-hand side of the equation. So press up to highlight the previous part, press right, and then press shift and left together. Now, fortunately, because it's a single fraction, it highlights the entire fraction at once. I'll then press enter to copy and paste it into the entry line, and I want to solve that to be positive. So control, and then the equal sign, and then greater than, and then 0, and we want to solve that for variable b. Enter. There we go. So the answer to our question is b less than negative 6 on 7 or b greater than 6 on 7. This corresponds to option D in our question. Moving on to question 2. So this time the question asks us the number of straight line asymptotes of the graph of y equals 3x cubed minus x squared plus 1 all over x squared plus x minus 2. Okay, so to get this question solved, first of all, I will open up a new problem just so that there's no, cross-contamination of variables between problems. So the way I'm going to do that is press Document, and then 4 for Insert, and then 1 for Problem. So this will create a new problem whose variables are not linked to any other problems. I'm going to add a calculator screen, and to find out the number of straight line asymptotes on the graph we've been given, I'm going to use the expand command this time. So menu, 3 for algebra, and 3 for expand. So now I'm simply going to type in the equation as it is. Control, divide, and then 3x to the power of 3, that's 3x cubed, minus x squared plus 1, and I'll tab over to the denominator. So x squared plus x minus 2. Now when I hit enter, I now have the expanded form. So the calculator has of course factorized the denominator. Not only that, it's gone and performed a long division on the expression, and then we've gotten this expression here. So we have 9 over x plus 2 plus 1 over x minus 1. Each, of course, individually contribute a single vertical asymptote. And then we have an oblique straight line asymptote, which is y equals 3x minus 4. So counting them up, we have 3 straight line asymptotes. So the answer to this question is D. By the way, this particular question is similar to the 2011 Exam 2 question number 1, which only 34% of students got correct. So the answer of that was D, as I just mentioned. Moving on to the next question. So this question is regarding the gradient of a specified hyperbola. And we're given a hyperbola, which is y squared on 8 minus x squared on 2 is equal to 2. The first thing you might notice with this question here is that it's a hyperbola that starts off with y squared, and the x squared is after the minus. So using our knowledge of hyperbolas, we know that this is an up-down or north-south hyperbola, as opposed to the usual east-west hyperbola that is the case when x squared appears first. This is a question that's very similar to the 2008 Exam 2 again. This time it was question 4, the multiple choice question 4, and only 26% of students got this one correct. So we're being given a bunch of options which regard the, domain or the range of the gradient of this particular hyperbola. So I'll show you an easy way to get this question solved. I'm just going to add a new problem again. So doc 4 and 1 to add a new problem. But this time I'm going to go to graphs. So down, add graphs. So I'm going to sketch this hyperbola straight away. So to sketch a hyperbola, I'm going to go to menu and then change the graph entry. So number 3, change that to a hyperbola. So I'm going to press 3 again for equation templates. Number 5 for hyperbola. And as you can see, east, west, and south, north. So as I mentioned before, we've got a south-north hyperbola. I'm going to press enter. And reading the question, we had y squared, so that's simply y minus 0 squared. Tap down to the bottom, and there's an 8 over there. So the 8, I can write that as 2 root 2. Or what we could do as well is that you notice that the right-hand side of the question was equal to 2. So before proceeding further, we can actually divide the entire equation by 2. So dividing by 2, the y squared on 8 divided by 2 turns that 8 into a 16. And similarly, x squared divided by 2, divide that further by 2, and we get x squared on 4. So going back to our graphing screen, that the denominator of y squared was 16, which is 4 squared. Tabbing along, and we have x minus 0 squared as before. And the denominator of x squared was 4, so 4 is simply 2 squared. I'm now going to hit enter. So now the calculator, of course, draws the hyperbola as you would by hand. But how do we figure out what are the possible values of the gradient? Well, a little known fact about the CX-CAS is that it can find and analyze the asymptotes of a hyperbola. And the way we do that is we press menu, 6 for analyze graph, 9 for analyze conics, and 6 for asymptotes. And once you do that, you simply scroll along to the hyperbola. And when you place your cursor over the hyperbola, you will notice that a lot of things appear. Before we proceed any further, let's just press Enter to fix it in place. I will then press Escape because we don't want to find any more asymptotes. I'll then just move these out of the way. And what you might notice is that the calculator has now given us the actual equations of the asymptotes. So one of the asymptotes with the positive gradient is y equals 2x. The other asymptote, which has a negative gradient, is y equals negative 2x. Now what this tells us is that every tangent along this hyperbola will basically, it'll start at 0 along the y-axis, both on the upper branch and the bottom branch. And as you move to the right, that gradient will slowly increase. However, as the graph approaches the asymptote, the gradient will never hit 2x nor exceed it. Likewise, if you go on the left-hand side, you can imagine a bunch of tangents over there. Their gradient will never go below negative 2. Just to make sure that we've got the right idea, we can go back to the bottom. And again, if you move to the left, as you can see here, the tangents will never increase past 2 in terms of their gradient. And on the right-hand side, the tangents will never decrease past negative 2. Therefore, the gradient, all the possible gradients on this hyperbola exist between negative 2 and 2, not inclusive. This corresponds to option D, which is negative 2 and 2 with round brackets because they're not included. Okay, moving on to the next question. So the next question talks about the solution of a trigonometric inequality. So we've got 2 sine of x being greater than half sec of x over the domain of 0 to pi, excluding pi over 2. So the best way to go about solving a question like this is, number one, let's create a new problem. Sorry, doc 4 and 1. Let's create a new problem. And then I'm just going to add a calculator. So the first thing we'd like to do is find out any points of intersection. So to do that, I'm going to use menu 3, 1 for solve, and then simply equate the two functions. 2 trig enter x, so 2 sine of x, is equal to control divide 1 over 2 half, and trig, let's go over to sec, so all the way to the right, half sec x, close bracket. Let's solve that for x and close the bracket again. And let's not forget the domain. So control equal, let's press left to snap to the given sign, and then let's type in the domain. 0, control equals, right for less than, x, control equals, right for less than, and let's type in pi. There we go. So we can see that the graphs of 2 sine x and half sec x, at least between 0 and pi, intersect at x equals pi over 2, as well as x equals 5 pi over 2. Now, to solve inequalities, the only way to solve them is via a graph. So let's go and graph these functions. Control I, and then press down to add a graph. So I'm going to now type in 2 trig sine x and enter, and then let's type in half sec x as well. So press tab or control G, both will work, to get back to the entry line. And let's press control divide 1 over 2, and I'm going to type in sec of x. So trig all the way to the right, sec of x. There we go. So we've now got the graphs of both 2 sine x and half sec x. Before we proceed any further, it might be a good idea to look at the domain. Right now our window settings are between -10 and 10. So let's quickly get these to 0 and pi. One thing you can do is you can actually just get them from the graph itself. So you can hover over the -10 and keep pressing the tab button until it says text. Then simply double click on the -10 and simply type in 0 and then enter. So that's the lowest x value that we've got. Now doing the same thing for the right x value. I'm hovering over there, press tab a couple of times so till it says text, double click it, and we can go to pi and enter again. There we go. So now we've got, without too much manipulation, we've got the graphs of 2 sine x and half sec x over here. As we saw in page 4.1, the x values of the intersection points are pi over 12 and 5 pi on 12, which you can see over here and over there. So we can see that 2 sine x is above half sec x between 5 pi on 12 and 5 pi on 12. There's a few options that have that, but there's another one that catches a lot of people out. Notice that between pi over 2, which is right in the middle of that domain, between pi over 2 and pi, even though 2 sine x and half sec x do not actually intersect, the graph of 2 sine x is always above the graph of half sec x from pi over 2 to pi. And therefore, the answer to this question is x element of pi on 12 to 5 pi on 12 union pi on 2 to pi, which is option D. Okay, so moving on to the next question. Please pardon my speed going through this. There's only 1 hour to get through all these 20 questions, and hopefully we get through all of them while you get to learn some new maths as well. Okay, so going to question number 5, we've got a function over here, which is g of x, being equal to cosec squared 3x plus sec squared of 3x. And we have to find out which of the following statements is false. Now, we get given 5 different options over here. And the way, when I see questions like this, I typically look for options that talk about equivalence relations. So what I mean by that is you have options that say g is identical to another function that looks slightly different, but also will take on the same values as the other ones. So the way to get through questions like this, I'm just going to again create a new problem, doc41. And the way to get through this is use a command called tcollect. The way to get to tcollect is press menu, then 3, then B, and then 2, tcollect. And I'm simply going to type in the function as it is. So trig, now cosec is CSC for us. Enter 3x, close bracket squared, and then plus trig, let's go to sec, 3x, close bracket squared, and I'm going to press enter. And I see that I've got a negative 8 over cos 12x minus 1. Now, if we look at the options that we actually have an option that is exactly equal to this one, and that option is option E. So option E is 8 over 1 minus cos 12x. On our calculator, we had negative 8 over cos 12x minus 1. Now, clearly, this means that the alternative option, which looks really similar, g is identical to the function where gx equals 8 over cos 12x minus 1, that is the false statement. Now, of course, you don't have to straight away take that on face value. You can actually look at all the other options and make sure that those are indeed true. For example, if you want to make sure that the derivative at pi on 12 is actually 0, which will make it a true statement, you can go back to your calculator and then perform a derivative. So quickly doing that, I can go shift minus, and I want to differentiate with respect to x, go back up over here, and simply copy out the function. So hold shift and keep pressing left until the entire function is highlighted. Press Control C to copy, and keep pressing down and then right, Control V, and then I'm going to plug in pi on 12 straight away. Control equal, left given, x equals pi over 12. And yes, indeed, it is 0. In a similar fashion, you can go through the other options and ensure that all of them are true. So this question was very similar to 2002 Exam 1, question 4, which 57% of students got correct. Moving next on to question number 6, we've now got a partial fraction decomposition. Now, the partial fraction decomposition questions can be done extremely quickly and efficiently. I'll show you right now how to get that done. Let's add a new calculator problem. All we have to do partial fraction questions is expand. To get that, you go menu, 3, 3 for expand, and then control divide. I'm simply going to type in the function as it is. 3x squared plus 10x plus 8, tab over to the bottom, and open bracket, 3x plus 4, close bracket to the power of 3, and then open another bracket, and we have x squared minus 4. X squared minus 4. Enter. And there we go. So we have one fraction with 3x plus 4 on the bottom, another fraction with 3x plus 4 squared on the bottom, and the final fraction with x minus 2 on the bottom. Now this might be different from what you might have initially assumed, which was three fractions regarding 3x plus 4, so one with 3x plus 4, another with 3x plus 4 squared, another one with that cubed, and two fractions with x plus 2 and x minus 2. But given the numerator, there would have been a lot of common factors which have cancelled, and that's why this is what the answer was. So going back to the answer there, our answer was, of course, E. This is similar to 2018 Exam 2, question 3, which only 46% of students got correct. Okay, so moving on to the next question, question number 7, a complex number question. So this question now talks about the number of distinct roots of a particular complex equation. Now it does say equation, there's meant to be an equal 0 over there, so pardon me with that. The way to get a question like this done, by the way, this is similar to 2017's Exam 2, question 3. Only 47% of students got this correct. So the key word over here I want you to look at carefully is the word distinct. So distinct simply means that if there's any repeated roots, they're only counted once, not multiple times. So creating a new problem, so 4 and then 1. I'm going to simply do C solve. So the way to get that is menu, 3, C, and finally 1. So that's C solve. It solves equations over the complex field. So open a bracket, Z to the power of 4, and then minus 16. Close bracket, open another bracket again, Z squared, minus 2, and then be careful. If you want to use the complex I, you have to find it in the pi menu. Do not press the alphabet I, which is on the keyboard there. So press I in the pi menu, 2I, Z, and then plus 8, close bracket, equals 0, and then comma Z. When you hit enter, now you see what's going on. We have Z equals 4I, 2I, negative 2I, negative 2, or 2. If you count that, there are only 5 solutions there. The degree of the equation will tell us that we should get 6 solutions, and indeed there are 6 solutions, but one of those solutions is repeated. And that's why there are only 5 distinct solutions, which means the answer is C. So moving through this now, let's go to question number 8. So question number 8 says, the set of points in the complex plane defined by magnitude of Z is equal to magnitude of Z plus 4. This is a question very similar to 2000's Exam 1, question 8, which 43% of students got correct. Okay, so to figure out this question, I'm going to, of course, start a new problem. So I'm going to go doc for 1, and I'm going to add a calculator page, and I'm simply going to type in the equation as it is. So press the template key right there, right next to the catalog book button, and then choose the absolute value signs over there. Press enter, and now type in Z. Now tab to get out of that, then equals, and then press that template button again. As you see, because we've just used that command, it's now ready for use next time as well. Press enter, and then Z plus 4. Of course, you can do this one by hand or without using a calculator, but it's always good to use your CAS to check up on these questions. And then I'm going to press Control equal, press left to get the given, and then let the calculator know that I want Z equal X plus Y, and then pi, go to I, and enter. There we go. So now what the calculator has done is subbed in X plus YI for Z and evaluated the moduluses. So now we can do a solve. So menu, 3, 1. Now typically when you solve these, you solve for Y. Now you will see later on that the equation is not actually Y equals in terms of X. It actually is X equals something. However, the calculator will still solve it for us. So I simply went solve. I pressed up to highlight the previous answer, pressed enter to copy and paste it in, and then I'm going to solve for Y as you would normally do. When you press enter, it gives us X equals negative 2. If you want to double check, you can of course copy and paste it again, change that Y to X, and what do you know? You get the exact same answer, which is X equals negative 2. Now X is equivalent to REZ, the real value of Z, in the Argand diagram. and therefore the answer is, of course, C. Moving on to the next question. So the next question, we are asked to convert from a Cartesian form into polar form. The calculator is very good at doing this. This particular question is very similar to 2001 Exam 1 Question 5, and only 49% of students got this correct. Okay, so to convert from polar form into, to convert from rectangular form into polar form, I'm going to again create a new problem and then add a calculator. And I'm simply going to type in I minus root 3. So pi right to I minus control x squared to get square root and root 3. And then press tab to get out of the square root command. Now, to convert to polar, I'm going to press the catalog or the book button right there. And then we'll press P because polar starts with P. And now press down until I see the convert to polar form. So I hit enter on that. So I want to convert I minus root 3 into polar form. Hit enter again, and here we go. So this is the Pythagorean identity for complex numbers, which is r e to the I theta is the same as r cis theta, as known in the specialist maths course. So as you can see, we've got a 2 there, which is our r value. And then next to I, the coefficient of I, is 5 pi on 6. So in polar form, the Cartesian complex number, negative root 3 plus I, is 2 cis 5 pi on 6. And that is option B. There you go, a nice quick way to convert from Cartesian to polar form. Moving on to the next complex number question, question number 10. So over here, we're on an Argand diagram. We are given 5 options, and we want the set of points which lies on a circle of radius 3 that is centered at the origin. Okay, so we've got various different options over here. Now, we can actually start eliminating a few options already. We know maybe from previous studies or previous work that we've done that z times z bar is actually x squared plus y squared. So having x squared plus y squared is equal to 3, well, that is a circle that is certainly centered at the origin. However, the radius is square root 3. That's out of the picture. B, z squared equals 3. Well, when you square a complex number, you still have i's in there. So that can't be it. We need an equation that gets rid of the I in there. Now, re of z squared plus im z squared equals 9. That's a possible contender. Let's sort of keep that in our toolkit. D, that looks quite a promising option. We can have a look at that. So I'm going to look at D. I'm going to type in the equation as it is. And very similar to question 8, I'm going to let z equal x plus yi. So creating a new problem with the calculator screen. And then I'm going to type in the equation as it is. So z plus, now to get conjugate, I need to get the conjugate of z. I'm going to press menu, 2 for number, and then 9 for number tools, and then 1 for complex conjugate. So conjugate of z, that is z plus z bar, close bracket squared, and then plus, do this, sorry, not plus, it's a minus. So minus, now do the same thing, open bracket, z minus, and then menu, 2, 9, 1 for conjugate of z, close bracket twice, squared, and equal that to 36. And before we hit enter, let's let the calculator know that it is z equals x plus yi. So control equals enter, z equals x plus y, pi, go over to I, and there we go. We have 4x squared plus 4y squared equals 36. Okay, this looks quite promising. I'm going to now simply divide everything by 4. And what do you know? We have x squared plus y squared equals 9, which is certainly a circle of radius 3 centered at the origin. So the option is D. This is a question which is similar to 2010 Exam 2 Question 10, which only 28% of students got correct. So quickly moving on to the next question, question 11. We've got parametric equations, x equals sine of 2t minus cos of 2t, and y equals half sine of 4t. We want dy dt in terms of t. Okay, so we can basically look at our formula sheet or use our reference book to see that dy dx is simply dy dt divided by dx dt. So the way I'm going to do this is I'm going to find the derivatives of y and x respectively, both in terms of t, and then simply divide them. Or I can actually do that in one shot. So press Control Divide to get the fraction, and then Shift minus for derivative, and let's differentiate with respect to t. Let's differentiate the y function, which is 1/2, and then sine of 4t. So 4t, there we go. Let's tab away to the bottom. Let's repeat the same thing for x. Shift minus d dt, press right, and now sine of 2t minus cos of 2t. So trig sine of 2t, close bracket, or you can just press right, minus cos, trig cos of 2t. And hit enter, and you get cos of 4t over cos of 2t plus sine of 2t. Now this isn't actually one of the options, so let's use something that we learned before, which was t collect. Let's try and get this together. So menu, 3 for algebra, and then B for trigonometry, as shown, and then 2 for collect. Let's press up, enter, and enter. Okay, so we get something completely different over here. So what we can do is we can look back at the original equation over there, and we can start modifying things. So, for example, you can take the sine of 2t and convert it to other things. So what is a possible option at the moment is to try and equate these to other options that we see in our options. So I can press up a couple of times, press enter, equals, and let's try the first option. So control, let's just add in cos of 2t, so cos of 2t, close bracket, minus, sorry, that's a plus, and then trig sine of 2t, enter. Okay, so that doesn't come up with anything, so maybe let's try the next one. I can press that up a couple of times, delete these, and then let's try cos of 2t minus sine of 2t. So trig cos of 2t minus sine of 2t. Okay, that doesn't come up with anything. So basically, with some questions, the trial and error on the calculator is most likely the best way to go about it. So let's try the next one, which was sec of 2t, and then plus cosec, which I can type in as CSC. And here we go, CSC of 2t, and enter. Okay, so that seems like it's not working. Let's try the next one, which was sec of 2t minus cosec of 2t. So press minus cosec of 2t. Okay, that seems to not be doing something as well. Let's go out on a limb and let's try the last one. And we have cos of 4t. Okay, so we have cos of 4t over cos of 2t minus sine of 2t. Enter. Okay, so we get something similar over there. Now, looks like with this particular question, something has not really worked out with the options of there. I'll just quickly double check. Half of sine 4t over sine of 2t minus cos of 2t. Okay, so I believe there might be a little typo with option E. I believe with option E, the denominator was meant to be a plus over there. Given the answer that the calculator gave us, it's cos 2t plus sine of 2t. I reckon that must have been a typo in the exam question there. So the answer to question 11 is option E. So when you differentiate and divide, you get the answer straight away. If that doesn't work out initially, you can try equating your answer to other options or using t-expand or t-collect. There's multiple options with trig expressions. Okay, so moving on to question 12, we've now got fx equals cos cubed of x, and we have to use the substitution u equals sine x to get the area bounded by the graph of f and the x-axis, which can be found by evaluating one of these options. Okay, so letting u equal sine x, the way to do this is you have to do it by hand you would expand cos cubed into cos squared multiplied by cos. You would then take the cos squared and convert that into 1 minus sine squared. So in that respect, if you let u equal sine squared, the derivative of sine would equal cos, and then that will take care of the cos x and the dx left over at the end of the integral. So we have 1 minus u squared left over in the integral, and the last thing to do is to change the terminals of integration. We can do that using our calculator. So when x equals negative pi on 2, our u would equal sine of negative pi over 2. So getting that sorted, I'm simply going to evaluate trig sine negative pi over 2. Sine of neg pi on 2 is, of course, negative 1. And then let's find what sine of 3 pi over 2 is. So now let's go to trig sine and then 3 pi over 2. That's also negative 1. Okay, so now looking at the options over here, we want the area bounded by the graph of f and the x-axis, and we notice that none of these options actually have negative 1 on the bottom or the top, and this is a little concern. So the way to do this is let's go and look at the graph and see what issues there might be. So I'm going to press Control I to open a graph screen, and let's see what the graph is doing, which might be causing the disconnect between our terminals and the answer here. Okay, so the function is cos cubed. So trig cos x, close bracket, and power of 3. Okay, so now we see something happening over here. I'm just going to change our terminals to negative pi over 2, and the upper terminal, let's fix that up, there we go, and that's going to be 3 pi over 2. Okay, so the area, the total area bounded by this graph and the x-axis, as you can see, there's a lot of symmetry happening. We have between negative pi on 2, that would be pi on 2 over there. So between negative pi on 2 and pi on 2, we've got a certain area. That area is the exact same area as the area underneath the x-axis between neg pi on 2 and positive 3 pi on 2. So in fact, the area that's being asked for is, but you can find it by finding the area between negative pi on 2 and positive pi on 2 and simply doubling that. So the upper terminal of our integral will be pi on 2. So before we put pi on 2, we have to find the new terminal in terms of u. So trig sine pi over 2, and there we go. So between neg 1 and 1 is the integral, is the area we want, and we simply have to double that. Going back to our options, here we go. So option C has double the integral from neg 1 to 1 of 1 minus u squared du. There we go. Option C is the correct answer. This question was similar to 2009's exam 2, question 10. Only 23% of students got this correct. Okay, so moving on to question 13, we're now looking at implicit differentiation. Not only that, we're actually looking at the second derivative. Now, these questions have been appearing a lot more commonly as of late, so it's always a good idea to be very proficient with using second derivatives with respect to implicit differentiation. Okay, so we want the relation e to the x inverse sine y plus e to the y inverse sine x equals 0, and we want the value of the second derivative with respect to x at the origin. This question is very similar to 2017's exam 2, question 6, which 46% of students got correct. Okay, so to get this question done, I'm going to again create a new problem, and let's add a calculator menu. So to get implicit differentiation, we're going to press menu, then and then for implicit differentiation, it's E. So menu for E for implicit differentiation. I'm now going to type in the equation as I see it. E to the power of x, tab out of that, and then trig, let's go down to inverse sine, and then y, close bracket, plus, press E to the power of y, press tab, trig, and then inverse sine of, sorry, not sine, inverse sine, so trig down again, that's better, inverse sine of x is equal to 0. So here's the notation for it, comma x, comma y. Now if I press enter, I will get the first derivative. I want the second derivative, so I simply have to press comma 2. That comma 2 is the order of the derivative. So second order means the second derivative. I press enter, okay, and I get the entire implicit, I get the function, which represents the second derivative. However, I don't want the actual function. I want the value at x equals 0, y equals 0. So I'm going to press up to get the question again, and then sub in x equals 0 and y equals 0. Control equal given, and then x equals 0, spacebar A and D, and then y equals 0. Press enter, and there we go. We get a value of 4, which is option C. Moving on, let's go to question 14. So we've now got an Euler's method question over here. This is very similar to 2001's exam 1, question 17, which exactly 50% of students got correct. So we want the solution of the differential equation square root 4 plus x squared dy dx equals 2 with x equals 0 and y equals 0. And we want to use Euler's method to solve it using a step size of 0.1 to get to x equals 0.3. So to use Euler's method, we simply have to use the Euler command. Now, to use the Euler command, you can press the book or the catalog. I'm going to press F to get to the bottom of E, press up a couple of times, and we should see Euler right there. Okay, so first things first is by hand, we would solve the equation to get dy dx as the subject. Once you do that, you will get dy dx equals 2 over the square root of 4 plus x squared. Now, the notation for this, or the parameters, is dy dx, comma x, comma y, comma, and then use the squiggly brackets, the set notation brackets, control and close the normal bracket. And we start with the initial x value, which was given to us as 0. Then comma, we give it the final x value, which is 0.3. Press tab to get out of, sorry, that's 0.3. Now let's tab all the way to the end. Now press comma again, and we want the initial y value, which was given to us as 0. And finally, let's type in the step size, which is 0.1. Press enter, and here we go. So you get given the Euler, the individual Euler steps for the new y values, the new approximated y values. So looking at the approximate value obtained for y when x equals 0.3, I get 0.29937, etc. And looking at the answers, we have 0.2994. So the answer is option D, 0.2994. Okay, moving on to question 15. So now we've got two forces, F1 and F2, that are acting on an object. We have F1 that's acting in the positive j direction with magnitude 2 newtons, and we have F2, which is acting in the direction of root 3i plus j with the magnitude of 6 newtons. Our job is to find the magnitude of the total force acting on the object in newtons. This is a question very similar to 2008 exam 2, question number 15, and only 36% of students got this correct. Okay, so to do force questions like this, or any vector questions for that matter, the best way to do that is to use the capabilities of vectors on your CAS. Okay, so F1 is in the positive j direction with magnitude 2, which means that I can simply type in a vector 0i plus 2j. To do that, I'm going to press Control, open bracket, which gives us square brackets, and I simply type in 0, 2, enter. So that is force F1. Okay, now to get force F2, this one's a bit more trickier because we get given a direction as a particular vector, but we want it to have magnitude 6 newtons. The best way to do that is to take 6 and multiply it by the unit vector of the direction vector. So to do that, I'm going to press 6 multiplied by, and then menu, 7 for matrix and vector, press up for vector, or you can press C as well, and then press 1 for unit vector. And now I'm going to type in the direction vector provided to us in the question. Control open bracket, and the direction vector given to us is root 3i, so root 3, comma, and then root 3i plus j, so that's simply 1j. I press enter, and here we go. So I've now got my second force. We know that the net force is simply the two of these forces added together. So I'm going to press up a few times to get the force 1, and press plus, press up, press enter again, and there we go. This is our final force. However, the question wants the magnitude. To get the magnitude of a vector, we press menu, 7, and then 7 for norms, and then 1 for norm. So the command norm is for the magnitude of a vector. Press up, press enter, and we get to root 13, which we see is option letter C. There we go. Moving on to question number 16. So we've got ABCD is a parallelogram, and we've got a bunch of position vectors in terms of a few variables over there. Okay, so given that ABCD is a parallelogram, we need to find the actual vectors connecting each of these vertices. The way we're going to do that is we're going to actually define these vectors in our calculator's memory. So doc for 1, add calculator, and let's define these vectors. A, and then control template to get define, then control open bracket to get a vector. So our vector A is simply negative 3k. So to type that in, it's 0i, 0j, and negative 3k. So that's A done. Now let's go to vector B, which is I plus nj. So B, control open new vector, and there we go. So we've got I plus nj, so that's 1, comma, n, comma, 0. Make sure that all your vectors have the same dimensions. They all have 3 dimensions there. Okay, now moving on to C. That is equivalent to, or we're defining it as 5i plus 2mj plus k. So 5, comma, 2m, and then comma, k. So that's simply 1, 5i plus 2mj plus k. And finally, our vector D. So D, let's define that again as a new vector. And we've got ni minus 2k. So n, comma, 0, comma, negative 2. There we go. Okay, so we got A, B, C, D. Okay, so we are told that this that ABCD is a parallelogram. That means that if you draw this out as a diagram, we have vector AB equaling vector DC. So to get vector AB, we're going to simply find what B minus A is. So using your vector rules, B minus A will tell us vector AB. In a similar fashion, we want vector DC. So vector DC is simply C minus D. There we go. So we know for a fact that 1i plus nj plus 3k and 5 minus n, 2m, and 3 are equivalent. So let's solve that. Menu 3, 1, solve, up, let's up a couple of times, enter, equals, up. So we're equating the vectors, and we want to solve for m and n. And we hit enter, and there we go. We get m equals 2 and n equals 4, which corresponds to option B. Excellent. Now we're at the home stretch. Question number 17. This one is similar to 2015's exam 2, question 22, the very final question of the multiple choice section, and only 42% of students got this correct. Okay, so we have a small pebble which is projected vertically upwards with an initial velocity. It's then subjected to gravity and air resistance, and we're given a differential equation for the acceleration of the pebble. That's given to us as d2x dt squared as negative g plus 0.3 v squared. We want the time taken for the pebble to reach its maximum height. Okay, now this can actually be solved as a differential equation because d2x dt squared is in fact dv dt. Okay, so we're going to simply create, again, a new document, and I'm going to use my differential equation solver. So to get differential equation solver, menu 4 for calculus, press up, and differential equation solver, as you can see, is option D. So we have the derivative of v, so that will be v prime, so v pi, and go all the way to the bottom there. V prime is equal to, and we get told it's equal to negative bracket g plus 0.3 v squared. So I'll use g, which is 9.8, which is given in the instructions of the exam, plus 0.3 v squared. Okay, so that is the differential equation. Now we need to give it the initial condition. So to give it initial condition, space bar, A and D, space bar, and we get told that the initial velocity is 7 root 213. So v bracket 0, close bracket, is equal to 7 root 213. Control divide, 7 square root 2 over 3. Let's solve that for t, which is the independent variable, and v, which is the dependent variable. Press enter, and now we get an equation that connects v and t together. So the question now talks about the time taken for the pebble to reach its maximum height. We know that the pebble reaches its maximum height when its velocity equals 0. So let's substitute in v equals 0. Press up, enter, control equal, left, given v equals 0. Hit enter, and we get an equation that has only t in it. Now let's solve that. Menu, 3, 1, up, enter, comma, t, and voila, there we go. We had t equals 5 pi root 6 on 126, which is, of course, option C. So 5 pi root 6 over 126. Awesome. So let's move on to our final few questions here. So we're now moving on to the sample mean and random variable distributions. Okay, so in this question, we have the length L and width W of a rectangle, which are independent, normally distributed random variables, where the length of the rectangle is normally distributed with the mean of 7 and a standard deviation of 3. The width is also normally distributed with a mean of 5 and a standard deviation of 2. So we want in terms of the standard normal variable z, we want the probability that the rectangle's perimeter is greater than 50. And you notice that all the options are related to the standard normal variable. The standard normal variable. So this question is very similar to the 2017 exam 2, question 18, which only 42% of students got correct. Okay, so what we need to do is we need to create the new variable for the perimeter and find its expected value, or its mean, and its variance, and then use that to figure out the number or the equivalent z value. Okay, so what we can do is figure out the new expected value, or the new mean. And the new mean is simply, remember the perimeter is twice the length plus twice the width. In other words, the expected value of the perimeter is twice the expected value of the length, which is 7, plus twice the expected value of the width, which is 5. So the expected value of the perimeter is 24. Now the variance of the perimeter is going to be 2 squared times the variance of the length, which is going to be 3 squared. So we're using the formula where the variance of ax is equal to a squared times variance of x from our formula sheet. We are using this because we are taking a multiple of each of the standard of the random variables that comprise the perimeter. 2 squared times 3 squared plus, again, 2 squared multiplied by the variance of the width. So multiplied by the variance of the width, which is 2 squared as well. There we go. So the variance of the width is 52, and the standard deviation for the width is, of course, going to be, standard deviation of the perimeter is going to be 2 root 13. So the equivalent z value for a perimeter of 50 is 50 minus the mean, which is 24, divided by the standard deviation, which is 2 square root 13. Enter, and there we go. So the equivalent z value is root 13. So for perimeter to be greater than 50 is the same as z greater than 2 root 13, or option C. Okay, so our time's almost up. Let's quickly get through questions 19 and 20. So we've got a random sample of 400 potatoes and a farm, and the total mass of them is 10 kilograms. We have a standard deviation of 4 grams as well. We want an approximate 90% confidence interval for the mean mass of potatoes. So before we get down to a confidence interval, we'd like to get, first of all, the sample mean. So the sample mean is simply 10 kilograms, which is 10,000 grams, divided by the 400 potatoes. So 400, there we go. So the sample mean for this particular sample is 25. Now, to get the 90% confidence interval, we're going to go menu, 6 for statistics, 6 for confidence intervals, and 1 for Z interval. We're going to change our data input method to stats, and our sigma, well, that was given to us as 4 grams. Our sample mean was 25 as we just calculated. N, we had 400 potatoes, and we want 0.90, the 90% confidence interval. I press OK, and I see a bunch of fractions. Well, that's because I'm in exact mode. So to get decimals, Control Enter, and that gets us the results. So our 90% confidence interval goes from 24.67 to 25.33, which is, of course, option A. Let's move on to our final question. So the length of time that a runner takes to complete the Melbourne Marathon is normally distributed with the mean of 4 hours and a standard deviation of 1 hour. So we want the probability that the average time taken by a random sample of 10 runners is less than 3.5 hours. Okay, so using our knowledge of the distribution of the sample mean, we know that the average time, the distribution of the average time will be 4 hours as it is with the population, but the standard deviation would have reduced. So if the standard deviation of the population is 1 hour, then the standard deviation of the sample will be 1 divided by will be sigma over root n, or 1 over root 10. So I'm simply going to go 1 over square root of 10 and hold that in the calculator's memory, Control C. So that is the standard deviation that of the sample mean. So this is simply a normal CDF question. Menu, 5 for probability, 5 for distributions, and 2 for normal CDF. We want the average time to be less than 3.5 hours, which means our lower bound is already at negative infinity. Awesome. Upper bound is going to be at 3.5. Our sigma, well, that's 4 hours, and our standard deviation is the new standard deviation of 1 over root 10. I press tab, I go enter, and I get 0.0569, which corresponds to option B. There we go. So this was similar to 2018's exam 2, question 19, which 57% of students got correct. Thank you so much for tuning in this evening, and I hope you all learned something new from this webinar.